Now, we know that these four squares all have to add up to 1. These are the four possibilities. Either they both live, one of them dies, or they both die. Very pleasant, isn't it? And so the probabilities have to add up to 1. Well, for a male alone, ignoring the female, 0.479 is the probability that the male survives. Well, either he survives or he dies. So the other 0.521, the 52.1% of the time, the male does not survive, regardless of what happens to the female. Now, again, we're assuming these two are independent, which may not be that valid of a thing, although that's what we are making. That's the assumption that we are making here. Now, we know that for the female, it's a 62% survival rate. So as female, regardless of what happens to the male, 62%. So the female does not die, or does not survive the other 38% of the time, 1 minus 0.62. Okay, well, we can actually find all of these by taking the products. So 0.62 times 0.479. So if we pull up a calculator and we say, all right, well, we know that the probability that the male and female survive is going to be, well, under independence, the probability that the male survives times the probability that the female survives. So that means that we take 0.62 and we multiply it by 0.479. And that gives us 0.29. We'll round it to about 0.30. That's good enough. So this is 0.30. Okay, well, at this point, we could be done in terms of having to multiply, because if 0.30 plus the male and female surviving, male not surviving and female surviving, have to add up to 0.62, that means 32% of the time the female survives but the male dies. So now we're actually bringing the male into the story. Similarly, these two, the male survives 47.9% of the time, 30% of the time the female also survives, so that means that 0.479 minus 0.30, which is 0.179, so 17.9% of the time the male survives but the female doesn't. And same type of idea here, we could go two ways. This plus this has to give us 0.38, and this plus this has to give us 0.521. I like this one a little bit better because I don't have to use a calculator here. This will be 0.201 plus 0.32 will give me 0.521. Similarly, if I double check here, this should give me 0.38, which in fact it does. So we notice that we only had to use the AND probability rule just once. We could double check this, like let me just check my last answer. So will I get 0.201 if I took 0.38 times 0.521? Now keep in mind there might be a little bit of rounding error, but shouldn't be too big. And we get 0.198. That seems reasonable given that we did in fact do a lot of rounding up here. So we're a little off, but this would round up to about 20%, and this rounds down to 20%. Similarly, we could do another quick check. Is 0.62 times 0.521 the product of the probabilities give us 0.32, and it does. So that must mean that we did things correctly either way. We could have multiplied, or we could have just done what we did here. Let's do one more here where it has us kind of thinking backwards. An insurance company finds that the probability an insured files an auto claim and a health claim in 1 year is 11%. The probability he only files an auto claim is 0.24%. Okay, so we're talking about, we want to know the sample space in this scenario. In other words, what are all the possible outcomes? Well, so we're dealing with two scenarios here. We have, again, I'm going to build a table. We have files a auto claim and a health claim. So we'll call this auto, I'll say auto, not auto. Health, not health. So either he does or he does not file each one of these, or she. But we know that 100% of the time one of these four things is going to happen. Either files both, files one, or files neither. Okay, well, what do we know? The probability an insured files an auto claim and a health claim in any 1 year is 0.11. So we know that value right there. The probability he only files an auto claim is 0.24. So that's this right here. Okay, well, we don't have too much information here. What we do know is that, well, this would have to be 0.13 for these two to add up. But I want to know, well, what is the probability he only files a health claim? So I want to know what is